Hello, everyone, and welcome to vCluster Fridays. My name is Sayam Pathak, and you are watching vCluster Fridays. I'm working as a principal developer advocate at vCluster Labs, and very excited to have Colt with me. So, if you are new, every Friday, what we try to do is we try to learn something new, something in the open source ecosystem, and then try it out on a virtual cluster created using vCluster. We have done a lot in this particular series, a lot of good projects with the maintainers. And today also, we'll continue the same tradition. And we have Colt, who is the founder and maintainer of LittleHorse. Welcome, Colt, to vCluster Fridays.
Thanks for having me, Siam. It's very exciting to be here, and hopefully today we can have a successful live demo because it's always scary when people are installing stuff not on my
Yeah.
computer, not in our cloud
It's
environment.
raw. It's so these streams are raw, live, and things might break. So if it works, it's a happy ending. If it doesn't work, then we'll figure out. We'll try to debug, and on the top of the hour, we'll see what's the end result. Um, but yeah, first things first, housekeeping items. So just please be good to each other in the chat, and I'll be sharing a link that is public for you to check out the doc because it has all the information. So just putting that in the comment section. And also, let me share the screen. So before diving into what I do as a little routine is some stuff that has happened. So this stream link I think is wrong, but I'll update that. Anyways, so today we'll be discussing about LittleHorse. That is final. So what's happening? vCluster launched 0.27 version, which is the private nodes. Now, this is one of the very exciting features. Till now, what virtual cluster was able to do, or vCluster was able to do, is it was able to create virtual clusters on the host cluster, and the resources and everything were from the host cluster itself. But this particular feature opens the doors to a lot more. So here, what you end up doing is you have something which is called a hosted control plane. So your vCluster control plane still is on the host cluster, but just as you do kubeadm join and join bunch of nodes to the cluster, what you can do is you can have additional set of VMs or bare metal instances, and then you can join them to the isolated hosted control plane. So this opens a lot of door. Yesterday, our founder and CTO, Lucas and Fabian, did a very good stream that you can check out on the vCluster YouTube channel on the launch. I definitely recommend you checking that out because this is a game-changing feature that we are adding to cover the whole multi-tenancy spectrum. Second thing is, and yeah, we also have vcluster.com/launch. So you'll be able to see what cool stuff we are coming up with and what we are launching. So the next launch is happening in 25 days. We have already made a lot of things public. So you can see the vCluster private nodes is launched 12th of August, and the auto nodes is launching on September 9th. So stay tuned for that as well, or you can just subscribe with the email over here. Kubernetes 1.34 is around the corner, and the sneak peek is always great. The DRA, which is for the GPU, it is getting more stable. And one of the cool things that I found is a new Kubernetes dialect, KYAML. So it's a successor to kind of YAML, and sorry, a YAML subset for Kubernetes, and very interesting. So this I think is coming as an alpha feature, if I'm not wrong. Um, but what do you think all about the KYAML feature? Do let us know in the comment section. Fine-tuned auto scaling for the HPA, and then you can see the whole change log over there. So every Kubernetes release brings a lot of cool features. Let us know in the comment section which ones you are most interested with. 13 arrivals from 2024 H2. the cloud native project. So this was posted on 11th of August, and there are a lot of cool CNC, a lot of cool projects in the CNCF ecosystem. You have Yoki, you have LockCLB, OpenEBS was, it has a story attached to that. I can explain that a little bit later on, but yeah, Persis, then you have OVN, Kubernetes, Kaito, Hami, and cartography, Servant, any of the blocks that you are using, sorry, any of the CNCF projects that you're using, do let us know in the comment section. And if you want any of these to get covered and you want to get them, I should try them out on a virtual cluster, let me know. I'll try to reach out to the maintainers and we'll get them on vCluster Fridays. That's what we do, right? And coming to another one, GitHub Actions for Gemini CLI is there. By the way, how many of you uses the, the Cloud CLI or the Gemini CLI, any of the AI CLI WAP or anything for your AI kind of workloads? Do let me know in the comment section. That would be good as well. Then what do you have is, yeah, this is something that we'll do today. Anything else that is pending? Let me see. All right, cool. So I think we can move to the next stage, which is what is a vCluster. So if you're new to the stream, vCluster is basically helping you to run virtual clusters on top of Kubernetes. So think of it as like you are running Kubernetes within Kubernetes, but the catch here is every Kubernetes cluster that is created using vCluster is having its own control plane. So, and you can see over here, when a user interacts with the virtual cluster, they are actually interacting with the virtual cluster control plane and not the actual host cluster, but everything is running on the host cluster. And then the component that syncs between the host cluster and the virtual cluster is the syncer component. Again, we have a lot of videos covering the basics of vCluster that you can check out on vCluster YouTube channel. We'll also create a vCluster once we get to know about LittleHorse. So Colt, now let's try to understand about LittleHorse. Like what is LittleHorse? If you want to share your screen, you can share your screen, or if you want me, I can hover around some of the stuff.
I will actually, if you could open that concepts page you're about to click on right there, that would be fantastic. So if you want to scroll down just to center the image a little bit, we'll try to explain what exactly LittleHorse is. So the engineering answer, not the marketing answer, is that today we're only interacting with one component of our platform. We have multiple components of the platform, but the core of the platform is what we call the LittleHorse kernel, which is it's built mostly for microservices. It's a distributed application management system that uses the concept of workflows to define processes that can be reliably executed across multiple different systems. So the core primitive of the kernel, which is kind of workflow heavy, and the rest of the platform is very focused on events, but we're going to focus on the workflow component today. The core primitive is this WIF spec, which is short for workflow specification, which defines a series of tasks to be executed in a process. So to run or to use the LittleHorse kernel, you first register a workflow specification, and then you tell LittleHorse to run it. And then LittleHorse will dispatch tasks to task workers. Now, those yellow boxes are client applications that use the LittleHorse SDK to talk to the LittleHorse server. And the brown thing, the LittleHorse server, is a cluster of, well, in this case, today we're only going to use a single thing, but it's an application that runs somewhere and can store state and dispatch tasks to task workers. So today we're going to deploy the LittleHorse server on vCluster. And LittleHorse server also depends on Apache Kafka as a backing store, as a commit log. So today we're going to deploy Apache Kafka and LittleHorse on vCluster, and we're going to use Strimzy to do it. So when you run a workflow, basically tasks get sent to the task workers, and then the results get reported back to LittleHorse, and LittleHorse keeps track of everything that has happened in your distributed process, and it gives you fault tolerance, observability, retries, and everything for free. So basically, when you write workflows in LittleHorse, it feels like you're programming a distributed system, but on a single laptop, because you have one file that controls everything. Okay, if you want to click on workflows, actually, that'd be great. There's a picture.
Yeah, I was actually about to ask, like, you mentioned like you have a client application.
Yeah.
And in that client application, you use the LittleHorse SDK to communicate with the LittleHorse server. And then you register the workflow step. But what exactly is this workflow? Like, what do you do in this workflow?
You can do anything. So right now you see an example where there's 2 user tasks, those blue boxes with a human in them, where we actually ask a human to put in some input. And then there's a conditional, which is like an if statement. It is an if statement, basically. And we execute a task with, well, in this case, it's the same task with different parameters depending on the output. And a task is basically have this computer run this Java, Python, Golang, C#, or whatever language you want. Well, those 4 languages we support right now, run a function or a method in those languages. And that can talk to an API, it can talk to a database, it can, create a new V cluster if you want to use LittleHorse to run infrastructure provisioning workflows, or it can charge a payment on Stripe if you're using it as part of an e-commerce platform. And there's also the ability to take in user input, which we're not showing today because of time constraints. But that's LittleHorse, and the problems it solves is it's hard to build distributed applications, and we are a platform that makes it easier to build distributed applications in an observable and reliable manner.
So basically, a workflow is a collection of tasks, and tasks can be anything like sending an email, creating a virtual cluster, spinning up a S3 instance, and stuff like that.
Exactly. And you can also wait for events from outside world, and you can you can also wait for input from humans. So workflows can wait, or they can be really fast at the same time. Yeah. So actually, if you want to go, well, I don't think we have I think if you go back to the concepts page, there's one thing missing. The only thing missing in the concepts diagram is a box for Apache Kafka, but we'll deploy that. And I think in one tab over to the right, we have a GitHub repo with a bunch of YAML files that should work to deploy LittleHorse on any Kubernetes cluster.
What is there? Like, if you can explain in a gist, what is there in this particular?
Okay, so
just we want to do like side by side.
What do you mean side by side? Like
I run the command and then you explain. You want to do like this, or you want to explain first and then we do the deployments and stuff?
I can explain really quickly. So we have 01 Kafka.yaml, and that's pretty simple. That deploys Kafka using Strimzi, and I've done a lot of talks about Strimzi. We probably don't want to go into this too much because we could spend hours and hours on Strimzi.
Yes.
It's a fantastic project. A huge fan.
Yeah. Just to let people know, Strimzi is basically Kafka on Kubernetes in a few minutes, in a nutshell. That's what we are trying to do over here.
Exactly.
Okay.
Yeah. So then you go back to lh.yaml. This one's a little bit more involved. This deploys LittleHorse, and LittleHorse needs persistent storage, and the LittleHorse server instances need to be able to talk to each other because it's a distributed system, kind of like a distributed database. So there's a config map that configures everything. And in this case, we only have a single server, which makes it a little bit easier. But if you scroll down a little bit further, we have a pod, and we just manually create a pod, and we create, actually, I'm using an old version of LittleHorse. That's my bad, but it should still work. Scroll down further, please. If we, then scroll up a little bit. There's a persistent volume somewhere. Oh, actually, never mind. We don't use persistent storage. We don't actually map a persistent volume just for getting it started. But we map a volume, and then we deploy the dashboard, which is a kind of administrative tool that lets you view what's going on in the workflows. So that should be it. If you could, do you have this repo cloned locally in VS Code, or you might have to make some changes?
I can clone it. That should be fine.
Yeah, you might have to make some changes. And I actually, or if you can wait, I can push a small change right now. I would like to use the latest version of LittleHorse.
I can do that. That should be fine. Git clone.
Yeah.
Lost. code. Okay. So I have this open. Let me share my complete screen. I hope I don't have anything funky on the screen.
Slack.
That yeah. The issue is when you share the window, then you have to share a lot of windows one after the other. And when I share the complete screen, then it's always difficult because there
Yes.
can be a lot of things that you are working on, which
If you want, I could just push a change. I'm just going to change the version to the latest. It was
no, I have to showcase the terminal and everything else. So it's fine.
okay.
Yes, tell me now. You should be able to see the right screen, and there we are.
Okay.
Yep.
If you open lh.yaml and search for
Yes.
13.2,
13.2. Yes.
if you change that to just latest, that would be
Got
great.
it.
Okay. And then the workflow pod. Okay, so this is all this is it's a pod that runs a Java application which is in the workflow directory. So if you want to open, what is the name of the file? Let me see. Hotel arrival workflow.java. That would be pretty cool.
Hotel arrival. Okay, this one.
Yeah.
Got it.
So this like line 13 defines our workflow. We take in as input a variable called customer or customer ID rather, and then we have an internal variable called is platinum. And then what we do is we fetch information about the customer and determine whether or not it's a platinum user. And if the user who has just arrived at the hotel is platinum, then we execute a send special welcome, and we pretend to send it to their mobile app a notification, saying, oh, we will give you a bottle of champagne or something in your room. Otherwise, we just go straight to processing the arrival. So this workflow simulates handling the event of a customer arriving at a hotel that they have a reservation at.
And these are customer inputs. Like these are the inputs that a user has to give, or
just the customer ID is the input. And then the is platinum is an internal variable that we assign to the output of the task that we execute on line 18.
Got it.
Yeah. And if you want to look at the, we're going to spoil a Star Wars joke, but if you open the know your customer tasks.java, this is how you define a task. It's just a Java method with an annotation. And line 12 is a bit of a Star Wars joke.
Okay.
Anyways, so you could do things like talk to a database, make an API call. You could even deploy a vCluster using whatever tools you would use for that, and you could send an email. Anything you can do in here, and same in Python and Java and Python, Golang, and .NET. It's very similar. And then lastly, if you go to main, I'll show you what we run. So I hard coded the host of the pod that we're going to deploy in LittleHorse for the LittleHorse server. And then what we do is we start 3 task workers. Line 14 through 20 are registering the tasks, right? Then what we do is we register the workflow that we defined in hotel arrival workflow.java. And then the last thing we do is we start the task workers. So line 31 through 34 is just starting the task workers. So this pod's going to hang out, and these workers are going to connect to LittleHorse, and they're going to pull, and they're going to wait until LittleHorse tells this worker, which is a separate pod, to run the tasks.
Got it.
Yeah. Okay, so that's LittleHorse. Now let's go try to make it work. We'll see if that actually happens.
Okay, now's the hard part. And so by the way, to create vCluster, you simply do vCluster create demo. Let me see if I already have a vCluster here. vCluster list. Okay, so I already have a vCluster, which is there. So let's use the vCluster, and this particular vCluster is actually the private nodes one. So let's try to use that. Kubectl config, kubectl config, get context. Every virtual cluster gets its context, and you can see kubectl get ns. We'll have this vcluster context, kubectl get pods hyphen n. You'll be seeing the control plane pod over there. So this is the main pod. But since this one is the private cluster, so this won't have the syncer component that we were looking at in the in the docs. But yeah, I have this vcluster, and if we want to save some time, we can. I mean, vcluster spin up just takes a few seconds. So vcluster create demo. I actually can do that. Oh, okay. The spellings.
Spelling is
Would
important. in
that
Bash.
isn't important, but yeah, the workflow is. So it starts using Helm to create. It creates a namespace vcluster demo, not demo, and then it starts to create the virtual cluster itself using this particular command. And you can see successfully created the virtual cluster, and then it is waiting for the virtual cluster to come up. It will just take some seconds to make it up because it's a stateful set that is getting up and running. And once it's ready, it will automatically create a new kubeconfig context and merge it with the main kubeconfig file. And then I'll be, instead of seeing two kubeconfig context, I'll be able to see three kubeconfig contexts. So let's wait for some time over here. Meanwhile, okay, we already have. Okay, so the issue here is that my Docker is not running, but that's fine. It's still handling the connection. So we should be able to get this thing vcluster rest and vcluster connect demo hyphen n.
Sam, while that's running, well, it looks like it's not running, but while that's running, could you also install the LittleHorse command line? I realize that you're going to be running everything. So
What is the command for that?
It's in the top of my README. It's brew install littlehorse enterprises /lh/lhctl.
I clicked somewhere else. Oh, no,
Right.
this one.
Yeah.
Got it. Let me run it here.
Thank you. All right.
And kubectl config get context. Okay, kubectl get pods. Let me do it here. Okay, cluster use context. Oh, not vcluster, sorry. Kubectl config. It should start now. The CLI is also getting installed. Let's wait for a second.
Now we play can you do LHCTL who am I or something like that? It should throw an error because you're not connected to it.
Who am I? Correct?
Perfect. That means you don't have a LittleHorse cluster running, but we should fix that. Hopefully.
Yeah. Okay, so kubectl get pods -a. So you can see we are now inside the virtual cluster, and it automatically switched the context to the cluster that we just created. All right, so now we are all set to install the LittleHorse. So we create this first namespace.
Yes, you probably should do that either way. Yes. Good catch.
Okay.
Bad readme. That should have been for everything. And then you want to get into that namespace.
Okay. I get into that namespace.
Okay. And you have Helm, right?
Yeah.
Okay. Perfect. So we're going to just install Strimzy and make Strimzy available so that we can deploy Kafka quickly.
Okay.
Then what we're going to do is we're going to deploy Kafka. And Strimzy is a little heavy. I love it to death, but it takes a little bit of time.
Okay.
Where's this vCluster running? Is it on your laptop or in the cloud somewhere?
No, it's on the cloud.
Nice. So we should see a Strimzy operator. And it looks like it's creating. Okay, it'll take some time to warm up.
Yeah, it's the readiness check that is happening right now.
Yeah, well, we can move to the next step, and it should be fine because the custom resource definitions already exist. kubectl apply this, and then do kubectl get pods -w, and we'll watch the pods coming up. And this is confusing. My apologies. The pods that say LittleHorse, LittleHorse 0, LittleHorse 1, that's kind of I named the resources wrong. It should be LittleHorse Kafka 0, LittleHorse Kafka 1, LittleHorse Kafka 2. We have a Kafka cluster with 3 instances right now, which is a slight mistake that they're named LittleHorse. That's confusing. Just bear with me. I'll probably go fix it on the repo afterwards.
Okay,
so they're pending, and the reason why it's pending is because it's waiting for persistent volume claims. That's shoot, I forgot. Can you do kubectl get storage class, please? Okay.
Yeah,
so we don't have storage. There's a change we can make. Let me look at the examples. There's a change you can make to make it use an ephemeral persistent volume, which actually is not type ephemeral. Let me push a change. And actually, yeah, I can push a change right now, which will allow the
no, we can have the storage class like.
Oh, you can create a storage class. If you could create a storage class, the name that I think it is expecting is called standard. If you can create a storage class, that'd be perfect.
Let me just update that.
Yeah, Kafka uses storage, and I think I used LittleHorse. LittleHorse uses an empty dir volume, which doesn't require a storage class, but it stores it locally on the node. Ideally, you use a persistent volume for LittleHorse as well, but just to make it easy, I tried to not use storage classes and forgot.
Yeah, so what I did is I just so this is basically the sync. So I'm saying that sync the storage classes from the host cluster to the virtual cluster. So what I'll do is I'll go back to the host cluster, kubectl get sc. You'll be able to see that I already have a storage class over here. And now what I'll do is vCluster. I need to upgrade this. So upgrade. vCluster create, upgrade, and we need to pass, I think, the name. Okay, vCluster list. What's the name? Demio something, right? DMEO cluster list. Yes. So let's do this. vCluster create. -n and -f. What did I create? vcluster.yaml. Yeah, this should restart it.
Okay. And then
Then we'll be able to see the storage class.
And we will need to change the name of the storage class in the Kafka YAML
okay.
to match what's available.
Got it.
Probably also best to delete the Kafka YAML and also delete the persistent volume claims to prevent grumpiness of some sort.
Okay.
Yeah, this is always fun, installing stuff on a new environment I've never seen before.
That's the fun of doing it live.
Mm-hmm.
Okay, kubectl get sc. So hopefully, sorry, kubectl get sc. We should be able to see the, yeah. So we have this now. This one is default. So even if you don't provide the name, it should automatically take this.
Yeah, I think get persistent.
So I should delete the Kafka one, right?
Yeah, and then also, yeah. Then could you do kubectl get persistent volume claim?
PVC. Yeah, right now there's nothing in. Oh, we have it actually.
Yeah, those are pending because that's the storage class that they expect is called standard. So why don't you delete those 3 persistent volume claims because they're going Strimzy. When you delete the Kafka custom resources from Strimzy, which is what we just did, Strimzy doesn't automatically delete the persistent volume claims because it wants to prevent fat finger catastrophe. So now we edit this Kafka node pool. Yes, a little storage class. Now that needs to be do dash whatever block dash something or something like that.
Got it. Let me get the name.
Do block storage. Yeah. Perfect.
All right, let's see.
Okay. Pod initializing is, that means it's running in an init container, right? Yes. Yes.
Yeah, it went from went to the next step after the pending state, so it's running.
That's exciting. That's exciting.
So a note to the viewers is that in vCluster, there is the concept of syncer. So if you want to sync resources to the virtual cluster or from the virtual cluster, you can use the syncer object. Just like I created a vcluster.yaml file with, did I do a cat of it? No, I don't know. But yeah, I'll show you once. Okay, this is running. So cat vcluster. So here I said I want to sync from host storage classes, which is why the next time when we upgraded the virtual cluster, we were able to see the storage classes. And you can see all the pods are up and running, hopefully. That's what it's, yeah.
Yes.
There's one, the operator is still, one of the pod is still getting in. Okay, it's running now. All are running.
Next step, let's deploy LittleHorse. So we have Kafka, and then the LittleHorse entity operator should be called Kafka entity operator. That helps the creation of Kafka topics, but I think actually we're not even going to use it.
So do we want to change anything in the LittleHorse YAML, or is it?
It should work, I hope.
Okay.
If it doesn't work, it's just a versioning issue, but okay. There should be 2 new pods.
Container creating.
It's pulling images.
One is running. The dashboard has got in.
The dashboard is very light. It's just an XJS app. LittleHorse server is
Takes a bit of time to download. Okay, it has downloaded. Now it is getting ready.
It should take
Let's
15
wait
seconds
for it.
max. Actually,
Okay.
no, it has to create topics in Kafka. It has to do setup the first time you start it. So give it a little bit of time. There we go. It's running. So let's test something if you could. Could you please kubectl and port forward, kubectl port dash forward,
Yeah.
svc/lh-littlehorse-server.
Sorry, kubectl get svc -n LittleHorse.
Missing the E.
Oh, we don't have any service.
Well, the name is
LittleHorse. Got it.
So
Yeah,
Little
which
Horse,
one do you want to do?
Little Horse, LH-Little Horse server, yes. And then 2023, 2023,
2023.
Yep.
023.
And then no P needed. And then all you need to do.
Oh, namespace. Yeah, I didn't give.
Okay.
Space.
So then in another pod, or sorry, in the other terminal window, right there, do lhtcl who am I.
Let me see if I have.
Yeah.
Wait, this is the right one?
Yeah, that should be. Just type lhtcl who am I again.
No, I just need to see I'm in the right context. Okay.
Yeah.
lsctl who am I.
And there you go. You are now connected.
So we keep this running. Do we need this, or we can?
You will need that later to. You can run it again. Well, yeah. Let's keep it running just to keep things easy.
Fine. I'll switch to this terminal. That's fine.
And don't. Well, yeah. So then apply. We need to go back into the repo, and then we're going to apply one more pod, which is
What was the repo name?
loft-littlehorse-demo.
Loft.
Yeah.
Yeah.
OECD.
Yeah. Got it. Now
we need to deploy the workflow pod. And what this is going to do is it's going to create a workflow specification and start some task workers. And
this is the image you built from the application that we just saw, right? This one.
Exactly. Yes.
Using this.
It's just going to run. Yeah. By the way, that was vibe coded, so don't judge that. The image, the Docker file was vibe coded. The code was handwritten.
Okay.
Yes. So just apply that, and it should just work. All right. And then can you do it's okay. Can you please do lhtcl space search? lhtcl space search space. Wait, well, and then you want WF spec, WF capital S PEC. Perfect. Oh, it didn't work. Did it? Try again. See.
Yeah, this pod went in error state actually.
Okay, why did it go to the error? Let's see. Unable to unknown host lh-littlehorse-server. So don't we have a service named that in the same namespace? Oh, what namespace? What namespace did you
given the namespace because this is deployed in the default namespace. Should I deploy it in the LittleHorse namespace?
It needs to be in the LittleHorse namespace.
Got it. So
yes.
Yeah, I was expecting that because I didn't switch the namespace. Now we recreated the cluster, right? So I haven't switched the namespaces to LittleHorse to work there by default. LittleHorse, LittleHorse.
Okay.
What happened?
Well, that's a vCluster thing. Every time there's a failure, and I'm like, is that my fault? Oops.
Okay. I think something went off. kubectl config. So we have, okay, we have this pod. Let me just remove this anyways. Or maybe let's do vCluster list. Connect again. Cluster connect. Okay, get pods. Delete pod. And kubectl apply -f03. Kubectl get po -n LittleHorse.
It's running. Wait.
Yeah, now it's running.
Okay.
So let us do the LH search. I have to
port forward.
Port forward.
Yeah.
And now, cool.
Okay. Now we have the customer arrival workflow created. Also, could you go one terminal to the right and then port forward to the dashboard? I'd like to show you the dashboard.
Okay.
kubectl get namespace.
I don't know if this has the YAML. Okay, this doesn't have. So X.
Actually, we can do this later. I think that would be better.
Okay.
We can go back to the other one. In my README, there's a LHCTL run command down towards the bottom. So if you copy the LHCTL run in the README.
Just a second. Too much stuff here. Yeah. And we come to the end.
LHCTL run customer arrival. Yeah.
Both or one?
If you run both, you'll get 2 workflows, which is fun. So just copy both and run them both.
Okay.
We already spoiled what's going to happen, but okay. Now we have 2 workflows that were created. If you scroll up, they're both running. Then go to the left. Go to the left. You don't cancel this. We're not going to use LHCTL anymore.
Okay.
Now port forward SVC LH-LittleHorse-dashboard, and then you want.
And what's the port?
3000, please.
Okay.
Okay, and then if you could go there, go to localhost 3000 in your browser. We'll see if this works. Oh, and there's our workflow. So you click on the click on that workflow. Click on customer arrival. Is it working? Oh, it looks like it's working. So we can see if we first fetch the customer, and then if they're platinum, we send them a special welcome. And if they're not platinum, then we don't send them a special welcome. And then afterwards, we process the arrival. So click view variables. Let's see what happens. I don't remember. There's some bugs on this version of the dashboard. So we pass in the customer ID variable to send special welcome. So let's scroll down. Well, we can also execute there, but let's scroll down for fun. And then let's click search by variable.
Search
to the right.
Okay, search by variable. Okay.
And then type in customer
platinum?
ID.
Okay.
And then click type OB1, capital O, OBI, lowercase
OBI?
lowercase with a B. like boy, dash, or hyphen, BI hyphen.
Oh,
It's exact match, unfortunately. We'll add prefix later. And then capital W, lowercase a, lowercase n. There we go.
Oh, okay.
There's our workflow. So let's click on this, and then we can see that it went through this path. Right. And then we can see the output of the output was true. And then if you click on the output right there to the right, click up. You can, if you click, just move your mouse a little to the right and click on that. Process, it says processed. Nope, up.
Okay.
There, yeah. You can see it processed the hotel arrival, right? That's what the task method returned.
Fancy. Cool.
If the task fails, you'll see the Java stack trace and so on and so forth. And you can see exactly when everything was executed. So if you want to do kubectl get pods one more time, just so I could show the concept. Dash and LittleHorse. So there's this loft LittleHorse. That's actually the pod that is doing the work. So the tasks are being executed on this pod, and you can have multiple tasks across multiple different pods. But for simplicity, we have only one pod that has all the tasks. And the server is keeping track of everything that's happening, and it's telling the loft LittleHorse thing to execute tasks. So the server just does things like retries, monitoring exceptions, and so on and so forth. And it gives you this control center for your distributed applications. All right, that's enough marketing. Are there any technical questions, or I don't really know how the Q&A works. If there is,
if there is any questions, please feel free to ask. I think we are done with the demo, right?
Yes, and actually miraculously it worked. So
yeah. So basically, this is your LittleHorse. So you have the client applications where you use the SDKs, and the SDKs are for all the languages, or what all languages are supported right now?
We support Java, Python, Go, and C#.
Okay, Java, Python, Go, and C#. So you can have that, and then you will start registering your workflow specification. What is a workflow specification? It's a list of tasks, and then you can define what all tasks are there in the specified coding language which you are comfortable with. And then it's the LittleHorse server that start dispatching these tasks one by one, and until the complete workflow is run. And since it's a workflow, so you have the track of whatever is running from one workflow task to another workflow task, but all variables can be passed in between the tasks. And then you can take actions on top of that. You can also take user inputs, and that will also be helpful when you have an error. That gives you the stack trace, as Colt mentioned, and also the tracing, like the whole trace path. If anything fails, where it failed, why it failed. So am I correct in all the things that I've explained?
You're correct. And if you want a job as developer advocate for LittleHorse, you're hired. So that was a very good explanation. Got it.
So yeah, there it is. I hope if there are any questions, please keep them coming. I'm sure Colt will be happy to answer any of those. So yeah, if it's open source project, LittleHorse, right?
Yes. Everything we did today was 100% open source. We have an enterprise Kubernetes operator that makes it a lot easier to install on Kubernetes.
Okay.
But
where is that?
Go to the docs. Click on docs again to the right.
Docs, okay.
And then enterprise products on the bottom, and then LittleHorse for Kubernetes. Yeah. I love open source, but eventually we have to, pay the bills. So, but I do like to keep the enterprise stuff separate from open source. But
so what makes this easier? Like, what is the feature that makes it enterprise?
Strong integrations with Strimzy and Cert Manager for security, also Keycloak, automatic scaling and so on and so forth, management of persistent volumes, management of TLS routes and ingress resources for north-south traffic, encryption of traffic between LittleHorse servers, basically a bunch of things that you want when you're running, mission critical payment workflows on top of LittleHorse. All of that can be done with the open source. It's just you have to be a Kubernetes wizard. So we put some Kubernetes wizardry into an operator that automates a bunch of stuff for you.
Nice. So yeah, anyone who wants to contribute to the open source project, please do check out this particular repository. I'll put that.
And please give us a star as well. That would help.
And give a star. And also, I think so these are interesting projects. I always get this when I'm, at conferences like KubeCon, that how do we get involved in open source? How do we contribute to open source? So this is the way. You get started with the project today. Go ping Colt and say that you're willing to help. And probably there's a lot of stuff which he wants to get done, and there are different languages that you can help in. Maybe Java, maybe Python, maybe Go, or whatever that is. So that's something that you can do. And thank you, APR, for that comment. That's lovely. There's one question. To implement tasks with Python or Go, do you need to use the LittleHorse SDK and build and deploy a custom container? Is there also a polyglot runtime planned? Example, define tasks directly via Kate's config maps. Example with simple inline Python code.
That's a fantastic question. We have something that we're working on with Java where you can upload a jar file to what's called the saddle control center, which is the idea is the saddle makes it easier to ride a horse. And that will allow you to deploy stuff in the LittleHorse runtime with Java, but we haven't yet thought of a CRD. That's a really good idea. A CRD that lets you put in inline Python code. That actually is a really good idea. I'll talk to the team about it, but don't expect it this year, unfortunately. Very good idea.
All right. And another one. Thanks for the great live session. So cool. Thanks, Colt. I think that was really, really fun. And it's always fun to do it live. And even I hope you learned about virtual cluster sync. We did it on the fly as well. Like nothing was prepared. All the live debugging that you saw was live.
Yeah.
Obviously, I don't have a clone yet. I might be in the future, but right now I don't have. Then I'll be there with LittleHorse as another developer advocate over there. So, anyways, thank you so much for tuning into vCluster Fridays. Today we learned about LittleHorse, the open source project by Colt. You heard from the maintainers that there's a lot of help that is needed. So an open source community make things fantastic. So if you are the open source wizard or Kubernetes wizard, do reach out to Colt. And is there any Slack or Discord, Colt, that you want to mention?
Oh, yes, there is. It's let me find the link. The link is right on top of our website. It should be easy to find. Yes, I'll put it in the comments right now. LittleHorse. Did it work? Oh, the comment is spinning. Oh, there we go. Yeah, launchpass.com/littlehorse-community/free. There we go.
So there it is. Can you send me that in the private chat so that I can also put this link in the docs?
Okay, I will try. I don't know where the private chat disappeared to me.
Oh, okay. I mean, you have the access to the Google Docs, so you can directly paste the link.
Yeah. I can just do that. But yes, please join our Slack. All sorts of stuff happens in there. We every couple of days someone posts a tip or we ask questions about things that we're working on, and contributors are asking for tickets and such. And every now and then we have users come and post screenshots of workflows they've built, and it makes me really happy. So please come say hi. It's a good, good channel.
So like I was saying, do join the Slack channel in the community, get involved, contribute to the open source project, and write fancy workflows. And I think that's something which always amazes me, the work that is going on in the open source community for easing out stuff and making a difference, making an impact. Again, thank you so much, Cole, for coming in on vCluster Fridays. And for people who are new, vCluster Fridays, every Friday, we try to learn something new in the open source ecosystem and how it works with vCluster. And do check out the vCluster 027 release and do follow the launch page, because we have very fancy launches coming up in future. And thank you so much for all for tuning in, and see you next Friday with another host, another guest. And yeah, keep liking, comment, connect with Colt on LinkedIn or on Slack, the community, and happy to. And also, if you have specific project that you want to see working with vCluster, let us know. We'll try to find the maintainer and get them hooked up for the vCluster Fridays.
Yeah, I actually kind of want to see the Strimzy maintainers do one of these, and we did very, very basic stuff, but I think there's a lot of interesting things you could do with Strimzy. So I might
we'll try to get them. Yeah,
we'll
if
try.
you can introduce me, to one of the maintainers, that would be good.
I'll message one of them and see if they'd be open to it. All right.
Awesome. Thank you, Colt, for this fantastic stream. Amazing demo. Worked like, butter smooth demo that worked. So it was really good. And thank you all for tuning in. See you next Friday.
Thanks, guys.